Awesome. Is the screen showing up? Can you all hear me?
Yes. We are good to go.
Wonderful. Wonderful. So let's get going. We're here to talk about device code phishing. And we're going to look at how it works, why it works, and more importantly, how to protect against it. So a quick introduction about myself. My name is Victor Hedberg. I'm a senior technical architect at a cybersecurity company in Sweden called TrueSec, where we do a lot of incident response, security research, etc., etc. So my bio on LinkedIn is, well, I do security stuff at TrueSec, and that's pretty much what I do all day long. So working with Microsoft technologies, whether it's on-prem or the cloud, unless it says SQL Server or SharePoint. That's not my boat. But in any case, let's get back to device code authentication and how to leverage that to perform phishing attacks. So this is no news for any of you, I hope. But basically, this is a description of the device code auth flow. So what happens is that anyone can request a device code authorization flow from anywhere at any time. So I can do it, any of you guys can do it, provided that you know how to actually do it. And one of the real issues with this, and we'll see that later on in the demos as well, is that, well, it's a legit Microsoft endpoint, right? So there's no way that any Defender for Office 365 or anything like that will actually catch this inside of email messages or Teams messages or whatever the preferred way of delivering the payload will be, because we're leveraging Microsoft backbone infrastructure. So if I create one, I can send it to whichever of you participants looking at this session. You click the link, you enter the code I tell you to enter, and then I can just curl for your access token. So that's the main issue with this. Now, of course, the device code auth flow is not valid forever. You have a small window of time where this link is actually valid or the access code is actually valid. But if you've done your reconnaissance properly and you have constructed a witty enough payload, you can trick users into doing this quite easily. And what it starts with is that we need to use a client ID. So this is the application for which we're asking an access token. Now, SecureWorks have compiled a list of family of client IDs. These are first-party client IDs. So, you know, Microsoft Office, Azure Active Directory PowerShell, etc., etc., etc. These are all referenced in different GUIDs throughout the Microsoft Entra ID infrastructure. So what we really need to do is that we need to figure out, okay, which application do we want to trick our users to sign into? Now there's a list of all of these that are known, and the list keeps on getting bigger and bigger. I know that Dirk-Jan Mollena and Fabian Bader did a lovely talk at Troopers like a month ago, where they also talked about the foci and how to bypass conditional access and stuff like that. So keep that in mind moving forward throughout this session. So this is actually a Microsoft 365 Copilot image of a computer virus. So now you all know how a computer virus looks like in the eyes of an AI. But how to construct a payload for a device code phishing thingy is that we need to select which graph endpoint we're going to target. So at the moment, we still have Azure AD Graph. It is in a retirement phase, but it's not fully retired yet. Meaning that, and I cannot underline this enough, the things that I'm going to show you will most probably work in your tenant or your customer's tenants until Microsoft actually removes Azure AD Graph API. So we need to select the graph endpoint. We need to select the delivery method of the payload, and we need to select a Foki app to leverage in order to get our access token. And once that is done, we simply need to wait for someone to actually click the link and enter the access code. And while I'm explaining this, it all sounds quite easy, right? And there are a lot of examples out on the internet on how to actually do this. So be wary, really. I mean, this is something that companies struggle with in this day and age. So in this demo, we're going to look at, okay, how can we actually construct this payload? So you see here we have a client ID. This is the Microsoft Office application. Now this can be replaced with another client ID from that list, like as mentioned, Azure Active Directory PowerShell, OneDrive Sync Engine, Intune Company Portal, etc., etc., etc. We're targeting graph-windows.net, which is Azure AD Graph. As I said, it's going out of business soon enough, but it's not done just yet. So if we go ahead and just hit run selection on this, you can see that this does not have any reference towards any tenant or any domain or anything like that. This is just, hey, give me a device, initiate a device code access flow. It's really what I'm asking PowerShell to do here. So if we go ahead and do that, like that, you'll see that, hey, we have a little device code popped up in here. And now what we're going to do is that we're going to basically wait for someone to click the link and enter the access code. So you'll see here it's polling, waiting, searching. So we have Microsoft.com/device login. We paste that little device code that I just generated. Yes, I'm trying to sign in. Yes, everything is fine and good. So if we jump back into PowerShell, you'll see that this loop is now closed. So if we check in this response.access token variable, you'll see that we have an access token. If we grab that access token and we paste it into, just to show you that, hey, I'm not actually tricking you or anything like that. We have an access token. Targeting graph-windows.net, the application Microsoft Office, and we have the username and everything in it. So essentially what I just did was that I phished my own global admin account in my tenant. Well, I knew what I did and I clicked the link and I entered the code and etc., etc., etc. But there is no way that any security product would actually pick up on this. Not by default anyway. Now, when I have an access token, I can actually do stuff posing as that person, right? So it really is this easy. If you only know, how to generate start the device code authentication flow, how to generate the code, the way of sending it, and you're golden. You can do this towards anyone. Now, I'm not encouraging you to do this towards anyone, but I'm telling you it's this easy. That's why we're seeing an uptick in device code attempts in phishing, and why Microsoft have constructed their own conditional access policy to block this. But it really is this easy. So switching back to the presentation, once we've gotten the token, we can do a lot of things. So if we're just a regular user, if I phish one regular user and I'm targeting Azure AD Graph, I basically have unhindered read access to the entire directory, like all your groups, all your users, all your privileged roles, all your conditional access policies, everything, everything, everything. This is one of the biggest reasons why Microsoft is trying to get rid of the Azure AD Graph API endpoints altogether, because they're way too overprivileged. In terms of Microsoft Graph, well, I can only do as much as the user is delegated to do in that context. So if I'm targeting a specific application, which is in itself privileged, or the user has delegated permissions towards that application, which are privileged, then I can leverage those privileges. This is all a matter of, how you're signing in and how you're presenting your access token to Entra ID. So if we're playing with Azure AD Graph, I'm going to show you some things that we can do in that sense. So in here, if we go ahead and just verify that I have an access token, let's see here. I do have an access token in here. I've already TV shift this. And you can see that this is a regular user. This is not an administrator. This is just a regular user. Okay? So if we go ahead and look at, you'll see here we're targeting graphwindows.net and users. So basically asking Entra ID to, hey, give me all the users of this tenant. So if we go ahead and look inside of the response variable, yes, all the users are here with whatever they consist of, like your proxy addresses, your licenses, if you have a thumbnail photo, etc., etc., etc. All of it readily available. Now this is another one which is quite funny. So you see that it's targeting graphwindows.net, Azure AD Graph, and it's targeting policies. Now, what's in policies? Well, all of your conditional access policies and authentication policies and authorization policies. So all of this is readable when you're targeting Azure AD Graph API. You can see this is also an authentication context, like, hey, you can only use Windows Hello for Business. Yeah, all of this is enumeratable via Azure AD Graph. You see here's a lot of conditional access policies. Everything, everything, everything. Readily available for you to consume. So if we just go ahead and pop another browser session over here, and we go to, yes, I'm still not super fond of using the Entra portal. So if we're using the Azure portal still, we sign in with the same user. I'm not authorized to read your conditional access policies this way. Nor if I were to use the legacy Azure AD PowerShell commandlets, like get Azure AD MS conditional access policy, it will give me an error saying that access forbidden. However, if I call the APIs directly, I'm greeted with the output. This is one of the major reasons why I'm speaking to a lot of customers around the issue with device code access flow, especially now that we're still waiting on Azure AD Graph to be fully retired. Because as you can see, I can read this. I shouldn't be able to, I'm not allowed to, but I am allowed to do so. Okay? So I actually reported this to the MSRC regarding the conditional access thingy that, hey, I think I stumbled on something that I shouldn't be able to do. And they said that, yes, this is basically, this is by default, or this is by design. You should be able to do this targeting those APIs. In my mind, that's you know, I get what they're saying. I'm not disputing that fact, but I'm kind of struggling to wrap my head around why this isn't a security issue. Since if I just have an access token, and this works if you're a guest as well, unless your guest settings are hardened. Why am I able to do this? Because any user can run the connect Azure AD and then loop through all these policies and build a map over, okay, these are your conditional access policies. These are the users they're targeting. These are the roles that they're targeting, etc. And you can then pinpoint your next attack vector, right? But fingers crossed, Azure AD Graph API will be retired fully later on this year. So let me just show you another fun way to use device code authentication to perform phishing, because this is just mwah. You can see here I'm using a PowerShell module, which is constructed by a friend of mine called Nestori Sinime. He's a Finnish security researcher. He's currently working for the mothership, so it's actually at Mystic at Microsoft. But the AAD internals module is a really fun one if you want to poke around in the underworlds of Azure AD graphs. So let's go ahead and give us a little sign in. So basically what we're going to do here is that we're creating an HTML version of a message, which we're then going to send to, well, the same admin user that I accidentally clicked the link and entered the device code in the previous demo. But in this case, we're going to use Teams to actually deliver the payload. So if we go ahead and run this, you'll see that we have a code, it has sent a Teams message, and now we're simply waiting for something to pop up. So if we go into Teams, you can see I've done this demo quite a lot, but here's a Teams message from someone named Victor Hedberg. It contains a link and an access code, device code. So if we click that link, it just redirects us to the device auth flow. We enter the code. Yes, we're trying to sign in. Yes, very well. And we have received an access token. So basically what I just did, but I leveraged Microsoft Teams to do it. Now this, of course, means that I need to have an email account to actually send the Teams message from. But this can be, I mean, if I compromise one user in the tenant, I can use that user to compromise another user or another user or another user, or even externally from another tenant. Now Microsoft have, they're requiring you to enter a credit card if you're trying to use trial licenses and stuff like that. But that's not the common modus operandi of threat actors. They usually target one user, they compromise that user, and then they use that user to compromise other users. So I get that. I get the trial thingy that it probably wouldn't work as easy anymore. But if I have access to one Teams account, I can do this. So if we go ahead and check our cache, you can see that, yeah, in here I actually have an access token for this particular administrative user, which is of course a bad day at the office, right? So if we go ahead and run this again, you can see that, yes, this is targeting the same API that I did previously in the other PowerShell prompt, but I'm using my global admin access token this time around. So is there any way for us to actually detect this in our environment? Well, yes, we can see it in the sign-in logs. And we can actually perform advanced hunting queries towards this particular authentication flow. Now we're talking strictly about the device code authentication flow, not talking about, you know, the weird shady graph API GET requests, but trying to catch the device code sign-in. Let's take a look at that. So back into our little demo environment, and we go to log in as our global admin. That was just phished. So if we take one of these ones, which is targeting Microsoft Office, we can see that original transfer method states that this is a device code flow authentication. Okay? So as I said, in the sign-in logs, we can see this clear as day that this particular sign-in was done via device code flow. Okay. Now I mentioned that we can actually hunt for this as well. So inside of advanced hunting, I actually figured out that if we construct a query looking somewhat like this, I'll go ahead and post it in the chat. Okay, I need to sign in again. Yeah, here we go. A query looking something like this. So basically any interactive sign-in being done where the endpoint call equals CMSI:CMSI error code 0, meaning this is a successful login. We can get all these sign-in attempts in Microsoft Defender. So this is the actual sign-in. We can see that the correlation ID ends with C3FA. And we go ahead and look at, it's probably that one. No, because that was a failure. Okay, that's not the same one. But in any case, this detection gives you something, right? Because there is really no table or any action inside of Microsoft Defender, to my knowledge, actually covering this. There is in log analytics. Like if you're using Microsoft Sentinel, you can actually hunt for, you know, where it was the original transfer method is device code flow, pretty much. But in Defender, we still don't have a clear-cut detection for this. But this can give you some sort of input on, okay, this user actually signed in via device code. Now you can construct a custom detection around this as well, triggering alerts, spawning incidents inside of the Defender console to actually be more proactive towards this. So as I said, running this, we can see, yes, here are some of the sign-ins correlating towards this particular advanced hunting query. So in terms of detection, we can look at the logs, we can look at the sign-in logs, We also have graph activity logs and even Azure AD graph activity logs to actually see, okay, what did you do? Which APIs did you target? What kind of data were you targeting, etc. So that's for detection. In terms of prevention, we can actually use conditional access to govern the device code flow altogether in any tenant. I mentioned earlier there's a Microsoft managed conditional access policy, which is being forced out into tenants left and right, which is a great idea. However, I would recommend creating one of your own because you have greater options in customizing such a policy. So if we look at what such a policy could look like, we have in my tenant, we actually have that policy, but in order to successfully demo the stuff that I just demoed, I needed to exclude myself from that policy. So the policy is targeting all users. Exclude is currently my global admin account. So if I were to remove that account from the exclusion, I would not be able to device code phish myself anymore. All resources, and here's where we target device code flow. So under conditions, authentication flowed, we say configure yes and check the box device code flow, meaning that we're only targeting device code flow with this policy. And the grant action on this policy is to say block. We're not allowing device code flow at all. Except, of course, if you really need it, because there are situations where you need to use device code flow. And in that case, you do a temporary exception for that particular user. So you add it to the exclusion group, or you add it to exclude it from the policy altogether, perform the sign-in, remove the exclusion. Because we don't want to keep people being regularly excluded from these types of policies, except for your break glass account or your emergency access accounts. So the device code flow is very well very well protected if you're using conditional access to govern access in that way. You can see I didn't even get the Microsoft managed policy in my tenant because I already had it. Okay, so that's for device code flow. What about the other things that I showed you where we're targeting Azure AD Graph? Well, we can only do so much, okay? Until it actually goes out of business and is no longer operational. We can do minor things to configure our conditional access policy framework. We can restrict, okay, which users can log into which applications. We can perform hunting queries on all of these things. But as I said, we can only do so much. So if we're talking about the Azure AD PowerShell application, that's the main entry point for AAD Graph API calls. You can actually register such Foci apps in your tenant as, well, they become sorta enterprise applications. You can see here, I have registered Azure Active Directory PowerShell, which always has this client ID. And since it is now registered in my tenant, I can actually add and remove people from this particular application. So you can see here that it only allows my admin account and another demo admin account to log in to Azure AD PowerShell. So if we actually try to log in via the connect Azure AD commandlet using my regular user account, So you see all the authentication is accepted. The multi-factor authentication prompt pops up, but I'm not allowed to log in. So this is one way to combat this type of action, okay? But as you can see, I was able to actually dump all of the conditional access policies, and I still am. So if we just go back to this one and we hit response.value again, I'm still able to do it. Why is this? Well, that's because I have targeted as a different application when I asked for my access token. So as I said, we can only do so much. All right, I can prevent the lookup via the Azure AD PowerShell module this way, but I cannot prevent the actual, dumping of data towards Azure AD Graph API endpoints, which is why I'm saying you can only do so much, right? And there actually are ways to hunt for non-admin activity where they're accessing specific applications or Azure AD Graph APIs. So as you can see here, this application ID is the Azure Active Directory PowerShell. So if you want to try to figure out which users in a tenant who are not admins, who are logging into Azure Active Directory PowerShell, you can go ahead and run that query. Now you're not getting any results in my environment because my end user was not allowed to log in. But you get the point, right? So there's a lot of moving parts in this, and it's hard to cover all areas and aspects until Microsoft actually retires this API stack. Yeah, that's the detection that I just showed you, and we've already done that demo as well. So I'm ahead of my presentation because I like doing demos rather than holding sliding PowerPoint slides. So that pretty much covers it when we talked about device code flow and what it means, how dangerous it is, why it's so successful, and how to actually prevent this. Now, I failed to mention that if we were to have a conditional access policy requiring strong authentication or a compliant device, etc., all of that will also help combat the device code flow sign-ins, of course. But start easy, just get that conditional access policy in play to block it, except for those who actually need it for the time being. So the remainder here, we have a couple of minutes left. I wanted to show you some of the other weird and cool phishing attempts that we've investigated at TrueSec. So this one is, well, not technically a phishing, but it's a link towards a specific website. Now, for a well-trained eye, there are things that immediately should throw you off. Specifically, the SSL verification on this site saying that it's dangerous. But in a Windows sandbox, we actually followed the steps here. So it said, verify that you're human. So we click that little checkbox. Now we're greeted with complete these verification steps. So Windows key plus R, and in the verification window, press Control V. Press Enter on your keyboard to finish. You will observe and agree, verify you are human, Ray verification ID, blah, 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 blah. So instead of, hey, click all the images where there's a bus, please execute code on your computer, if you will. And this is what we were greeted with. And if we look at the source of that, it was actually an MSHTA exploit. Tricking users into executing code on their systems. So one of the immutable laws of cybersecurity states that if a threat actor can trick you into running their code on your computer, it's not your computer anymore. Case in point. Another one, which was really, really big one a couple of years back, was that they used teams to deliver a malicious payload. So in this case, starting a group chat circumvented all of the, accept this message from this external sender, etc. So if I just targeted 15 users at a company, I immediately started a group chat with those 15 users. So this zip file was hosted on a Microsoft SharePoint online site, and it contained, a shortcut disguised as a PDF which invoked cmd.exe, which invoked curl and executed auto-it, etc., etc., etc. And in the end, you were greeted with the Dark8 Loader ransomware virus. So this is one of the ways. It's not really phishing, but it's more of, hey, click this link, view the vacation schedule, and bam, you have Dark8 Loader on your computer system. This is a more recent one. This is actually from this year. So you can see this is an image of mail flow towards a specific user. And you can see that there's a bit of a difference in the mail flow. So this wasn't actually phishing. This was just, a dump truck full of spam email landing in this user's inbox at a specific date and time. So hundreds and hundreds and hundreds of spam email just flooding the user inbox. What the threat actor did next was to reach out to that particular user via Teams chat and say, we're from IT support. We have noticed that you have received a lot of spam email. Would you be so kind as to share your screen and give us control so we can actually take a look at what's wrong with your system? The unsuspecting user, of course, agreed to this. That allowed the threat actor to download and install a remote access Trojan onto the user's system, giving the threat actor unhindered access to that system after the Teams call had transpired. And since the spam email stopped, because this was a targeted attack, the end user was, blissfully unaware that anything had happened. There was no antivirus detection, lack of EDR, etc. So this is actually from the timeline itself. So we see that a Teams call was initiated on the 4th. They social engineered their way into her computer, and on the same day, like 3 hours later, the threat actor was able to achieve domain admin persistence by exploiting a vulnerable certificate template. So, one of those certificate templates that says, hey, supply subject name in the request. Yeah, that's one of the templates that they used. Got one for domain admin or like administrator, and then just logged into the main controller, starting exporting the Active Directory database, etc., etc., etc. So 3 hours was all that was required in this particular case for the threat actor to initiate a Teams call, get a remote access Trojan onto the computer, and become domain admin. Thankfully, we were able to stop this attack by performing mitigating actions in a production environment, which was not easy. But this particular customer was thankfully unaffected by any ransomware because we were able to stop them and kick them out before they were actually able to do any real damage. So this session I've been talking a lot about different things. But device code phishing is a real threat that you actually need to consider in your environment. Please use those advanced hunting queries that I left in the chat, and for the love of God, please create that conditional access policy to block this from happening in your tenants. I will leave a couple of seconds for people to come off mute if they want to and ask questions. Other than that, thank you so much for having me.
Hello guys, if you have any questions, please unmute yourself.
Or write them in the chat, or reach out to me on Twitter or LinkedIn or whatever. I can actually write my social.
Yeah, you can post your LinkedIn profile URL in the chat window. It will be really helpful for the guys if they want to contact you back.
All right.
Thank you. Thank you.
Thank you very much.
Thank you.
Take care,
Thanks
everyone.
Bye.
Bye.